grade, welcome to your second lesson. In this lesson, we're going to be talking about powers and exponents. So our objective is to write and evaluate expressions that involve powers and exponents. And the standard that we're going to be addressing is 8th grade standard, equivalent expression standard number 1. What I'd like you to do now is pause the video, copy this down, put it as your header on your notes, which means the topic. Then, go ahead and pause the next slide, because the next slide actually is going to have all your vocab words. Instead of me writing them down, you're just going to be able to copy down what you see. Alright? In example 1, go ahead and pause the video, copy down the directions, and copy down the problem. I'm going to go ahead and show you how to do this problem. It says write the expression using exponents. So right now we have something that's expanded out. Our job is to condense it and put it in exponential form. So what we have to do is look at what things are different, and those are our bases. So I have a negative 2. That's a number that keeps getting multiplied, and I see that negative 2 comes up 3 times. Well, the negative 2 must be my base, because a base is a number that's getting multiplied, and how many times it gets multiplied, that's my exponent. So what I do is I write my base first. My base is negative 2. And my exponent is how many times did I see that negative 2 was getting multiplied? Well, it's negative 2 to the third power, because there's 3 negative 2's. We're taking negative 2 to the third power, timesing it by 3. That's my other base. And now we count how many 3's we have. Well, we have 4 3's, so that must mean that that's 3 to the fourth power. Now, when it comes to negatives, I recommend putting a negative inside parentheses, because if you're trying to do a negative in your calculator, to type this in and actually get the right answer, your calculator doesn't really take into account that the negative is going to go to all 3 2's. So you always want to put your negative number inside parentheses if you're going to be typing into a calculator later. So this is negative 2 to the third power because we have 3 negative 2's, and this is 3 to the fourth power because we have 4 3's. And we're taking this times that. So this is expanded form, this is exponential form, where we're actually using an exponent to represent the same numbers. Let's go ahead and do our next problem. For our second example, we have the problem, write the expression using exponents, kind of similar to the first one. And in this one, again, we have to use exponents. We need to have it in exponential form. We're in expanded form, where everything's written all expanded out. We want to condense that down. So as in the previous example, we count how many of the same number we have. And since it's the same number, that must mean it's our base, which is the big number. Well, we have 5 negative 9's, so I'm going to write negative 9. And since it's a negative, I'm going to put it inside parentheses, because if I use it inside parentheses, my calculator will get it right. But if I don't use it inside parentheses, my calculator might get it wrong. So it's negative 9. I see 5 of those, 1, 2, 3, 4, 5. So negative 9 to the fifth power times, count the 4's, there's 3 4's, 4 to the third power. And remember that a power just tells us how many times that number was multiplied by itself. So exponents are these little tiny numbers, and they tell us how many times they're multiplied by themselves. This number is the base, the number that keeps getting multiplied. So this is exponential form because we're just using exponents. Let's go ahead and do some more. Alright, for our third example, we're going to be writing the expression using exponents. This time we don't actually see numbers. What we see is we see variables. Now, a reminder that variables really are numbers. So what we're going to do is kind of the same purpose. We see that there's 2 different letters here. There's A's and there's B's. Those must be our bases. So what we do is we say how many times do we see those coming up, and those are our exponents. So A, since everything is multiplied, I have A 2 times, so that's A to the second power, times, and then I look at the B's. B's have the next letter, and I count how many I have. Well, I have 3 of those, so that's B to the third power. So this is A to the second power times B to the third power, because I have 2 A's and they're all multiplying, and I have 3 B's and they're all multiplying. As long as everything's multiplying, we can change it to exponential form, because the rule of exponents is that you're multiplying the same number. And that's how we can change it to exponential if we keep having the same number come up and up. Let's go ahead and do another one. So on to the fourth example. If you feel like you can do this after we've already just done 3, go ahead and pause the video, try this, put it in exponential form. Write the expression using exponents. Again, I'm going to go ahead and solve it, so if you didn't pause the video, that's okay. I see that I have the letter X and I have the letter Y. And when you do this, you actually want to keep it alphabetical. I forgot to mention that in the last problem. So you want to talk about which letter comes first in the alphabet. That usually goes in the front, and which letter comes next in the alphabet. That goes second. And remember that they're really not letters. They're actually variables. They represent unknown numbers. So I have X and I have Y, and all of it's multiplying, so it's really X times Y. I count how many x's I have, that's 4. So my exponent that goes with x is 4. Count how many y's I have, and that's 2. So this would be my answer to this problem. It's x to the 4th power times y to the 2nd power. In example 5, what we're doing is we're evaluating negative 2/3 to the 4th power. Now, a base is the number that's being multiplied where the exponent tells us how many times it's being multiplied. Evaluate just means that we have to figure out the answer. So we're going to figure out the answer of negative 2/3 to the 4th power. I'm going to write the base 4 times because that's what my exponent tells me. So I have 1, 2, 3, 4 negative 2/3. And that's what that exponent told me. Now, evaluate means to solve. If you feel like you need to use your calculator, that's okay, but we're going to try to expand it out and solve it without a calculator. Whenever multiplying fractions, we multiply the tops first, and we multiply the bottoms second. But since we have a negative in here, and I'm going to make this look like it's a negative now. Since we have a negative in here, we have to actually multiply the negative through first. And remember, anytime we have a negative times a negative, that's a positive, and a negative times a positive, that's a negative. So anytime they're opposite, it's a negative. Anytime they're the same, it's a positive. A negative times a negative, that's a positive. A positive times a negative, that's a negative. And a negative times a negative, that's a positive. So I know right now that the fraction that I'm going to get for a final answer has to be a positive, so I'm putting a plus sign that just says, hey, that's a positive at the end. Now we're going to go ahead and multiply these numbers. 2 times 2, that's 4. 4 times 2, that's 8. And 8 times 2, that's 16. So I have a positive 16. Now I figure out the denominator. 3 times 3, that's 9. 9 times 3, that's 27. 27 times 3, that's 81. So my final answer of a negative 2/3 to the 4th power is actually equal to 16 over 81, or 16/81. For example 6, go ahead and pause the video, copy this down. This says we're going to evaluate 1/4 to the 3rd power. I'm going to approach it just like we did the previous one. Right now it's written in exponential form because it has an exponent. My job is to expand it out and then solve it mathematically using rules that I've known from past. So I have 1/4 times 1/4 times 1/4. And I know this is the base because I see it's this number to the 3rd power. And the reason why the 1/4 is inside parentheses is because this whole thing is going to the 3rd power, which means we see the whole thing 3 times. If only the 1 was being seen 3 times, the exponent would be inside the parentheses. So if it's outside the parentheses, that whole thing inside the parentheses happens that many times. Now we're going to approach this the same way we did the previous one. Multiply everything on top. 1 times 1 times 1. That equals 1. 4 times 4, that's 16. And 16 times 4, that's 64. So in this problem, my answer is 1 over 64, or 1 divided by 64. This fraction is 1/4 to the 3rd power expanded out and solved. In example 7, we're talking about area. It says the deck of a skateboard has an area of about 2 to the 5th power times 7 square inches. Our job is to figure out what is the area of the skateboard deck, which means that we're actually going to solve or evaluate 2 to the 5th power times 7 mathematically. I'm going to expand this out so I can solve it a little bit easier. The 2 is the base, the 5 is the exponent, so that means I see the number 2 5 times. 2 times 2 times 2 times 2 times 2. So I have 5 2's. We're going to multiply that by 7. I'm going to make these a little bit dark. Because it's 2 to the 5th power. There's 2 to the 5th power times 7 times 7. Now we're going to figure this out. And when we multiply, we start from the left and we work our way to the right. So 2 times 2, that's 4. 4 times 2, that's 8. 8 times 2, 16. 16 times 2, 32. So we have this whole thing right here is actually equal to the number 32. So I'm really taking 32 and multiplying it by 7. Since I don't know 32 times 7 off the top of my head, I'm going to do this the way that I learned math by writing 32 times 7 this way. 7 times 2, that's 14. I'm going to drop the 4 down, carry the 1. 7 times 3, that's 21. 21 plus 1, that's 22. So the skateboard deck has an area of 224 square inches. So I'm going to label it as inches to the 2nd power because that's what a square could be. So we need to put a label on it because in the problem we see that there's a label here. Square inches, inches squared. Same thing. 224 inches squared is our answer to this problem. Let's go ahead and do it. For example 8, you can pause the video if you need to copy this down. It says that we have a racquetball court. It says a racquetball court has an area of 2 times 4 to the 2nd power times 5 to the 2nd power area in square feet. What is the area of the racquetball court? So we're actually trying to figure this out. So again, this is written in exponential form. We're going to actually write it in expanded form by writing it all expanded out and trying to solve it that way. So we have 2 times 4 times 4 times 5 times 5. Because 4 to the 2nd power means I should see 2 4's. 5 to the 2nd power means I should see 2 5's. And we can approach this the same way if we'd like by doing 2 times 4, that's 8. 8 times 4, that's 32. So I know this right here is equal to 32. Now I'm actually going to look at the 5 times 5 and I'm going to put that together too. As long as we're multiplying, the order in which we multiply doesn't matter, and that's called the commutative property. As long as all the numbers are multiplying, we can multiply whichever numbers we want first together. And we can move them around. 5 times 5, that's 25. So in this problem, we really have 32 times 25. And I'm going to go ahead and solve that, but I'm going to go ahead and solve it by writing it over here and solving it without a calculator. We have 32 times 25, and I'm going to solve it by doing it hamburger style, where everything's stacked on top. Now to do this, you take the first number, which is 5, you multiply it to both of these numbers first. 5 times 2, that's 10. You drop the 0 down, you carry the 1 over to 3. 5 times 3, that's 15. Add the 1, 15 plus 1 is 16. So 5 times 32 is 160. So I have my first number. Now when you start the second number, it's starting in the 10th spot, so you're going to put 0 in the 1 spot. Now I'm going to erase that 1, and now I'm going to take this 2 and I'm going to multiply it by 32 since I'm starting in the 10s. We don't have anything in the 1s because we're starting in the 10s. 2 times 2, that's 4. 2 times 3, that's 6. And now, with these two numbers, all you have to do is add them together. 0 plus 0, that's 0. 6 plus 4, that's 10. Drop the 0 down, carry the 1, it's going to add now. 1 plus 1, that's 2. 2 plus 6, that's 800. So in this problem, my answer should be 800. I'm just going to go ahead and double check. I'm going to use a calculator. I'm going to type in this sentence right here, which is 2 times 4 times 4 times 5 times 5. And in fact, I do get 800. Check my work. Good to go. That's the right answer. Let's do another one. For example 9, it says that we need to evaluate the expression if we know that the letter A equals 3 and the letter B equals 5. So in this problem, we have a squared plus b to the 4th power. One of the first things we're going to do is we're going to use the information we see up here and we're going to replace it into the problem down here. I know the letter A is 3, so where I see the letter A, we're going to change it to the number 3. And this is actually called substitution. Substitution is when you take what you know and you replace it into where it can go. B is 5. So I see the letter B, I'm going to write the number 5. So the problem that we're really looking at is 3 to the second power plus 5 to the fourth power. 3 to the second power plus 5 to the fourth power. Again, right now it's written exponentially. I'm going to write it in expanded form. I might use my calculator for this one because I have 5 to the fourth power. So go ahead, if you need to have a calculator ready, make sure you have a calculator ready. It's going to help us out in this problem. 3 to the second power means 3 times 3. Then we have a plus sign. 5 to the fourth power means 5 times 5 times 5 times 5. Now, in order to do this correctly, we need to know what Pemdas means. Pemdas means we have to do anything inside parentheses, exponents, multiplication, division, addition, or subtraction. And it matters about which one comes first. So what actually we have to do is we have to do multiplication before we ever do addition. So anything that's multiplying, we have to solve first. 3 times 3, I know that one without a calculator. That's 9. If you need a calculator to check that, you can. So I have 9 plus. Now I'm going to use a calculator to solve this. So I'm going to type in my calculator 5 times 5 times 5 times 5. And this means that we have 625. So this problem is 9 plus 625. Now I can do that in my head. If you need to use your calculator to check that, that's okay. This is actually going to be 634. So if I had a squared plus b to the fourth power, and I know that a is 3 and b is 5, when I solve it, I should get 634 as my final answer. Let's do another problem just like this one. In this problem, we have evaluate the expression if x equals 4 and y equals 2. So they're telling us what x is equal to and y is equal to in this problem. So I see the letter x, I'm going to go ahead and replace it. That's 4 to the third power plus, well I see the letter y is 2, I'm going to replace it here, 2 to the fifth power. So I have 4 to the third power plus 2 to the fifth power. I'm going to go ahead and expand that out just like we did the previous one. 4 to the third power is 4 times 4 times 4 plus 2 to the fifth power is 2 times 2 times 2 times 2 times 2. So again, this is expanded form because it's all written expanded out. 4 times 4, that's 16. 16 times 4, that's 64. So I know this number on the left side is 64. If you didn't know that calculators can be used 4 times 4 times 4, just type that in, press equals. 2 times 2, that's 4. 4 times 2, that's 8. 8 times 2, that's 16. And 16 times 2, that's 32. So the problem we're looking at right now is really 64 plus 32. 2 plus 4, that's 6. And 3 plus 6, that's 9. So this has an answer of 96. This one I didn't need a calculator. The other one I did, it got all big numbers like 625. This one's pretty small, easy to work with. If you need a calculator, by all means, please use it. Let's go ahead and go to our last two problems. For our next example, it says evaluate the expression if we know the letter A is 3 and we know the letter B is 5. So again, first thing we're going to do is replace those. So notice that this time we're working with parentheses. And Pemdas, or please excuse my dear Aunt Sally, which is the order of operations, tells us that we have to do what the P is, which means parentheses. We have to solve what's in the parentheses before we do anything else. So I'm going to replace the 3 into the letter A. So I have 3 minus 5, and this is inside parentheses. The entire thing goes to the second power. Okay, so in 7th grade last year, you should have maybe worked with positive and negative numbers. 3 minus 5, that's a negative 2. So we have negative 2 to the second power. Now, this means negative 2 second power, which means that we're going to write that number twice. So I'm going to expand that out. Negative 2 times negative 2. A negative times a negative, that's a positive. And 2 times 2, that's 4. So this answer to the problem should be a positive 4. Good to go? Let's do our last problem. For our last example, we have x plus y squared. And it says that we're going to evaluate the expression if x is 4 and y is 2. So we know that x is 4, there's an x, we're going to change it to the number 4. And we know y is 2, there's a y, we're going to change that to the number 2. So really, we have this problem here. We have 4 plus 2 inside parentheses still. 4 plus 2 is 6, because we have to solve inside parentheses. And then we have 6 to the second power. I'm going to go ahead and expand that out. 6 times 6, well, that equals 36. And that is my final answer. So we learned today how to take an algebraic expression and replace those numbers and solve them if they involve exponents. Make sure you have your questions. If there's anything you struggled on, make sure you have your notes. Be ready for tomorrow.